Hey guys, what's up? Here's another example of quotient rule. So I want to find y prime, and I notice that I'm dealing with a quotient. Sine x over cosine x. You might recognize that. So what I'm going to do, we talked about low, d, high, and all that good stuff. So this is my low function. This is my high function. Get it? Because the high is on the top, low's on the bottom. So our rule is low d high minus high d low over low low, or low squared. All right, there's our quotient rule. That's the way we're going to remember it. So if I want to find y prime, I got to do the low, so that's cosine x, times the derivative of the high, and the derivative of the high would be, the derivative of sine is cosine, minus high, so sine x, times the derivative of the lower one. The derivative of the lower one is negative sine x, all over low low, which is cosine squared x. Alrighty, let's do some simplifying here. Let's call this cosine squared x, and a negative negative, so plus sine squared x. Oops, I can't write. All over cosine squared x. Now you might remember from pre-calc that this is a special identity. That is our Pythagorean identity, and cosine squared plus sine squared is equal to 1. So I've got 1 over cosine squared x. And I know also from pre-calc that this 1 over cosine is like saying secant. So 1 over cosine squared would be equivalent to me saying secant squared x. So you probably already knew that the derivative of tangent was secant squared x, but we kind of just proved it. Yay!